Welcome to Peshawar Model School, Nashera campus. Don't forget to subscribe our YouTube channel so you will watch our upcoming videos. I'm your chemistry teacher, Ms. Faradiba. Today we will continue our chapter number 9, class 10 chemistry, chemical equilibrium. And we will do the exercise of chapter number 9, chemical equilibrium. Okay. Let's do the first question. The first question is choose the correct options. The first is at dynamic equilibrium. The first option is the reverse reaction stops. The B option is the forward reaction stops. The C option is both forward and reverse reaction stop. The D option is both forward and reverse reaction continue at the same rate. So, as we discussed in our topics that at dynamic equilibrium, both forward and reverse reactions continue at the same rate or at the same speed at the same time. So, this one is the best option for this question. Okay, the next one is a reversible reaction have the following characteristics except means that for the reversible reactions there will be all of the options except the one. So the first one is they proceed in both direction. The second is they never complete. The third is products do not form reactants again, and the fourth one is they are represented by double arrow. As we discussed in our last topic in the summary and at the key points, that reversible reactions are those reactions which proceed in both direction, forward and backward direction, and they never goes to be complete. They are represented by double arrows. So the best option will be the products do not form reactants again, because this is best for the irreversible reactions. So this is the best option for this second one question. Okay, the third one is the equilibrium constant Kc expression for the given reaction is. Okay, look at this reaction. Here 1 mole of nitrogen react with 1 mole of oxygen gas and it will give 2 moles of nitric oxide. So the first option is 2N molar concentration of 2N, molar concentration of 2O, and molar concentration of 2 nitric oxide. The second one is 2 moles of nitrogen, 2 moles of oxygen, and here is 2NO. So here is not 2 mole of nitrogen and neither 2 moles of oxygen, so this will be not suitable. Also this is not suitable. The third one is nitrogen, molar concentration of nitrogen, molar concentration of oxygen, and 2 moles of nitric oxide. And fourth one is this is if you see in the case of moles, so this is correct, but we can't write this Kc expression like this, because for the Kc expression we should have to write the product on the superscript and the reactants in the subscript. So this is incorrect. At the last we can see that 2 moles of nitric oxide, that will be right on the superscript, and in the subscript molar concentration of nitrogen and molar concentration of oxygen. So this is the best option for this third one question. The fourth one is the equilibrium constant Kc is the sum of the two reactants, the difference of the two rate constant, the ratio of the two rate constants, and the products of the two rate constants. So this one will be correct, because the equilibrium constant is the ratio of the 2 rate constant means the rate constants for the products to the rate constants for the concentration of the reactants. So this is the ratio of the 2 rate constants. So this will be the best option for the equilibrium constant. Okay, the fifth one is when the value of Kc is very small, it shows that reaction will go in forward direction, reaction will go in the reverse direction. C is reaction is at equilibrium, and D is equilibrium will never establish. Okay, when the value of Kc is very small, it shows that, okay, first you should have to exclude all the irrelevant options, so you will better choose the correct answer. So first look at this D, equilibrium will never establish. This is most irrelevant. The C is reaction is at equilibrium. So this is not also suitable, because if the value of Kc is very small, so it means that that reaction will not be at equilibrium. Okay, the reaction will go in the forward direction. It will also be incorrect, because if the value of Kc is very small, and we know that Kc is directly proportional to the concentrations of product, so if the Kc is small, so it means the products are also lower in concentration. So if the products are lower in concentration, it means that they will not go in the forward direction. So the best option will be the reaction will go in the reverse direction. Okay, the sixth one is for which reaction the Kc will have no units. The Kc will have the unit if they didn't cancel out each other, and the Kc units are mole per decimeter cube. So look at here at first. Here is 4 moles of ammonia react with 5 moles of oxygen, and it will give us 4 moles of nitric oxide and 6 moles of water. So here is when we write the Kc expression, so we will write in the numerator concentration of products, and in the denominator we will write the concentration of reactants. So for the products we will write the unit of Kc 4 mole per decimeter cube and 6 mole per decimeter cube, and in the denominator we will write 4 mole per decimeter cube and 5 mole per decimeter cube. So when we add this up this add up this mole per decimeter cube, so in the numerator we will have 10 mole per decimeter cube, and in the denominator we will have 9 mole per decimeter cube. So 9 mole per decimeter cube will cancel with 9 of this 10 mole per decimeter cube, and we will get the unit of Kc will be equal to mole per decimeter cube. So this is incorrect option for this sixth one. The next one is 1 mole of nitrogen gas react with 3 moles of hydrogen, and it will give us 2 moles of ammonia. So if we write the Kc expression for this one, so we will write the product in the numerator and the reactant in the denominator. So if we write the unit for this product, so here we will write 2 mole per decimeter cube, and in the denominator we will write 1 mole per decimeter cube and 3 mole per decimeter cube. So at the numerator we will have 2 mole per decimeter cube, and in the denominator we will have 4 mole per decimeter cube. So 2 divided by 4, and what will get 2 of 4 mole per decimeter cube will cancel with this 2 mole per decimeter cube, and we will get 1 by 2 mole per decimeter cube. So this will not also suitable for this 6-1 question, because for in this case he will have no unit. Okay, C option is, when 1 mole of nitrogen react with 1 mole of oxygen, it will give us 2 moles of nitric oxide. So 2 mole per decimeter cube, and in the denominator we will have 1 and 1, 2 mole per decimeter cube. So these 2 mole per decimeter cube cancel out these 2 mole per decimeter cube, so we will have no unit. So this will be the right option. And if you look at here, so here is 1 mole per decimeter cube, 1 mole and 3 mole of hydrogen. So, and here is 1 mole of methane and 1 mole of water. So here is 1 mole per decimeter cube and 1 mole per decimeter cube, and in the denominator here is 1 mole per decimeter cube and 3 mole per decimeter cube. So here is 2 divided by 4. So 2 divided by 4, what we will get? 1 by 2. So 1 by 2 mole per decimeter cube. So the right option is C. Okay, now the 7th one is, when the value of Kc is very large, it shows that the reaction is at equilibrium. No, it is totally irrelevant. The reaction will be at equilibrium if the rate of forward and rate of backward reaction will be equal, or the concentration of reactant and product will be equal or at the constant. So this is incorrect. The second one is, equilibrium will never be achieved. So it is also incorrect, because it doesn't relate with the large value of Kc. Now the reaction will move in the forward direction and the reaction will move in the reverse direction. These are the two options in which we have to choose. So if the Kc value is very large, it means that the concentration of product will be higher, or with the concentration of product will be more, because Kc is directly proportional to the concentration of reactants. So if the Kc value is very large, it means that the products will be moved in higher concentration. So it means that reaction will move in the forward direction, or reaction will be completed in the forward direction. So this will be the right option. Okay, now the 8th one is, active mass is means. The first one is the total mass of reactants. No, it doesn't only relate with the mass of reactants. The second one is the total mass of products. No, it doesn't relate with the mass of products. The third one is the total mass of products and the reactants. No, it doesn't about the mass of the products and reactants. The last one is the concentration of reactants and products in mole per decimeter cube in a dilute solution. Yes, this is the correct option, because active mass means that in any dilute solution or molar solution, we should have to know the concentration of reactants and products in mole per decimeter cube, because the mole per decimeter cube is the unit of the concentration of reactants and products. So this is the best option for the active mass. Okay, the 9th one is for a reversible reaction. This is the Kc expression. This is for the reversible reaction which are mentioned below. Kc expression is equal to the concentration of C, and this 4 shows the 4 moles, and divided by the concentration of A, and this shows 3 moles concentration of B, and this 2 shows moles of B. Okay, the equation will be, the first one is 4 moles of carbon will react and will give us 3 moles of A and 2 moles of B. No, it doesn't. It is totally incorrect, because for the Kc expression we should have to write the product in the numerator and the reactant in the denominator, and in this equation here C is the reactant and A and B are the product, so this is totally incorrect. In the second option also 4 moles of carbon will react and will get 1 mole of A and 1 mole of B, so this is also incorrect because for in the case expression C is the product and here the Cr is the reactant. Okay, the C1 is when 1 mole of A and 1 mole of B react together, it will give us 1 mole of carbon. This is also incorrect because here 4 coefficient shows 4 moles of carbon. So this C must be the product and this 4 will shows the 4 moles of carbon. So 4 moles of C. So this is also incorrect. Look at the D option. When 3 moles of A react together with 2 moles of B, it will give us 4 moles of carbon. So this is the right option because here you can see the 4 moles of carbon in the numerator and in the denominator 3 moles of A and 2 moles of B. So this one is the best option. Okay, now the 10th one is the reaction between phosphorus trichloride and chlorine will produce phosphorus pentachloride. This is the reversible reaction. Look at here, 1 mole of phosphorus trichloride react with 1 mole of chlorine molecule and it will give us 1 mole of phosphorus pentachloride. As we know, the Kc expression is equal to the concentration of product in the numerator and the concentration of reactants in the denominator, and the unit of Kc is the mole per decimeter cube. So what we will have to do, Kc is equal to we will have to write phosphorus pentachloride in the numerator and concentration of phosphorus trichloride and concentration of chlorine in the denominator. So if we write down their units, so this will be equal to Kc is equal to mole per decimeter cube divided by mole per decimeter cube and mole per decimeter cube. So here is 1 mole per decimeter cube and here will be 2 mole per decimeter cube. So this 1 mole per decimeter cube cancel out with this mole per decimeter cube, and after that we will get 1 by 1 mole per decimeter cube. So that will be equal to per mole per decimeter cube. So this is the right option for this 10th question. I hope you will understand this question. Question number 1, choose the correct answers in the exercise of chapter number 9, chemical equilibrium. And if you have any problem in chapter number 9 and if you have any question in this exercise first question, so you are welcome. You can ask me in the comment section. I will give you the answer.